So to restate, we're going to talk about the metric system, and not in exhaustive detail, but we're going to talk about the parts that we need to know in order to make good measurements here in class, and to know a little bit about how the rest of the world functions, since the rest of the world, with only a few exceptions, uses the metric system. And we'll discuss how not so much how they're similar, but what different measurements would we use in the metric system that we're used to using in what we call the imperial or English system that's used in the US. So let's first talk about something that's everywhere in the metric system, and we even see it creeping into different parts of our own measurement systems that we'll use, and that is how they name different sizes of measurements. So each size is going to start out with some sort of base unit. So this could be like a meter or a gram, etc. And then there are every step is named. So if you do 10 times the base unit, or 100 times, or 1,000 times in steps or multiples of 10, it's going to have a name, and it's going to be written out like that. But in practice, we really only use about every 1,000th. So that's all we're going to practice. So the next one we are going to care about is 1,000 times bigger than the base unit. Anyone know what that's, what do we call, or what prefix do we use in the metric system for 1,000 times bigger?
Is it the thing that has the number times 10?
No, we're not using the scientific notation is what you're referring to. We're saying, like in meter, if we took 1,000 meters and put them together, we would call that a blank meter. It's kilo, right. You guys can shout out. You can even be wrong sometimes, and that's okay. It's a prefix, kilo, and whenever we see that prefix kilo, it means the same thing. It means 1,000 of whatever comes after it. So kilometer, kilogram, kilobyte in computers. It's not quite exactly 1,000 because of how computers are built, but it's very, very close. If we continue to go up, we would also see mega, and that's 1,000,000 times. And we could see giga, and that's 1,000,000,000 times. Here in class, those are nice to know because we come across them so often. That's the one you need to know for class. Actually, let's do mega too. Those two. Giga we won't really ever use, and even mega is only used sometimes. It might be used in energy measurement. Megawatt we use to measure. Giga is we use all the time in computers. We don't use it too much else outside of that. And they keep getting named, and like I say, the times 10 and times 100 are also named, and the times 10,000 and times 100,000 are named. But in practice, nobody ever uses those, or at least almost never. So we aren't going to worry about them either. Down, now when we start cutting it up smaller, we actually do use the 1/100th measurement. At least and we use it in length mostly. So if you take a meter and you chop it up into 100 smaller pieces, what do we have? What's the distance there between my fingers? First hour. Centimeter. Centi. If you have $1 and you chop it up into 100 equal pieces, what do you have? A cent. Same reason. It's a penny, yes, but but it's 1 cent. So this is centi. So whenever you see a centimeter or a centigram, you'll know, oh, that's 1/100th, just like a cent is 1/100th of a dollar. In practice, we really only see this with centimeter, and that's because a centimeter this far is such a convenient measurement for a lot of what we hold in our hands and that sort of thing. We use meter because that's a convenient measurement for things like rooms and whatnot. We don't usually use centigram because it's so tiny. But the next common one would be 1/1000th of the base unit. And in my meter stick here, that would be the finest lines here. So if I cut this meter stick into 1,000 pieces, they'd all be about that big. Milli, right, millimeter in this case. And the prefix is milli. The next step, since usually we go by factors of 1,000, is actually 1/1,000,000th of a base unit. Anyone know what we call 1/1,000,000th? That would be, in length, taking one of those millimeters, cutting it up into 1,000 equal pieces. That one we call micro. So it could be a micrometer, which we sometimes shorten to a micron, or it could be a microgram, which would be an extraordinarily small bit of mass. Then there's one more piece that I want to put on here before we go off and start looking at actual examples of some of these, and that is how do we abbreviate each one. So every time we make a measurement, and almost every time we write down a number in this class, we will also have some units that it's measured in. And we usually don't want to write out the whole name of the unit, we would abbreviate it some. So the way that we would abbreviate it depends on how many we have, depends on the prefix. Does anyone know what the abbreviation for kilo is? Just a K, lowercase k. Anyone know mega? Think about computers, megabyte. We only use one letter. Yeah. Can you be more specific? Think about, and think about when you say M, what is milli? And what is mega? Capital M up here. What about milli? Lowercase m. Centi we all have seen lots. C. Giga we see in computers, that's a capital G. And that leaves our little friend micro. And we've already used both of them. It's not a capital, it's actually the lowercase, but it is fancy. It's like that. It's actually the Greek letter. If you look right above the board, I'll turn it up even, you can see a little kitten. Right? What sound does a kitten make? It doesn't say meow. Kittens don't have that good a vocabulary. It says mew. 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 That's what this is. It's the Greek letter mu or mu. It's the Greek letter equivalent of M. And we use it because we needed another sound for our prefixes, and that was a handy one. In practice and in what we're doing in class, as I said, we'll talk about mega, kilo, definitely centi and milli, and I think we'll do micro too. We won't worry about the giga, although that is a pretty common one that we come across, so it would be a good one to also know. But definitely these, we will need to know what kinds of things might you measure with them. So let's talk about that. There are 4 categories of measurements that we're going to make fairly often. Let's talk about the one that you're probably most familiar using the metric system with, length. Length and distance. What's our base unit in the metric system for length? Meter. That's why we call it, partly why we call it the metric system. We abbreviate it with a lowercase m, which is sort of like the milli, but if we see only a single lowercase m, we'll know that it's a meter. If we see a lowercase m followed by something else, whether it's this or a g or whatever, we'll know that it's a milli, whatever that is, milliwatt or millimeter or whatever. This was the basis for the metric system. It dates back to the early 1800s when Napoleon was conquering Europe. And he conquered a lot of Europe. But what they found was that every place they went in Europe had its own measurement systems. And they didn't match up with the country next door or the county next door even necessarily. And so that made it really, really hard to try and build an empire if you can't even talk the same language, like saying, oh, I want a board that is 8 feet long. Well, 8 feet over in this village might be different than 8 feet over in this village. So trade was a challenge. And so he set some of his scientists to figuring out, he said, give me a better way to measure, and then we'll spread it across the empire that we're building. And they being learned men, women wouldn't have been included in this. If they had, they might have done something differently. But they said, oh, we want to do something very educated. So we are going to make this meter mean something on Earth. So they said, all right, well, we know the distance from the North Pole to the equator. We're going to divide that up into 10,000 equal pieces and call each of them a meter, because it'll be about this long. That's good. It worked. They were wrong. They didn't have the measurement correct. But at the end of the day, it really didn't matter. They could have picked up a stick on the ground and said, this will be our meter. And it would have been just as good. That said, here's what we've got. And there is a platinum, which is an extremely valuable metal. Platinum meter stick in Paris, France, that's preserved, that is defined as a meter. We now define it as the distance that light travels in a vacuum over a certain very, very, very tiny amount of time. But for all intents and purposes, this is just as good. So they said, okay, that's going to be a meter. And we're going to base everything else in our measurements off of that. What kinds of things might we measure in meters? Not in kilometers or millimeters or anything, but in meters like this. What's one thing? Yeah, rooms or buildings. What else? What, in the U.S., what unit or units would we use to measure things that are like rooms, buildings, that are around this size? A yard. We would, and what else? Let's see some hands. You guys all know measurements. If you were asked to measure this room, My bet is you probably wouldn't measure the size in yards. What other common unit would you measure today? We're gonna get somebody else. We're gonna wait for one, somebody over here. We have 6 people, all of them know. Yes, feet, right. So, in the metric system, instead of using feet or yards for a measurement, we've used meters. So thinking of that, we've got rooms and buildings. What else do we measure in yards or feet? You already answered, thank you, but you already answered. Yes, yeah. You bet, people are measured in meters typically. What else is measured in feet or yards around here? Think of something. Sure, tables. Those are all good examples, and we don't need an exhaustive list. Tables. Most of that table in front of you would have been measured in feet, and it might not be, exactly 2 feet, but we'd say some number of feet. Okay, then let's get bigger. Let's take 1,000 meters. Kilometers, which we'd abbreviate K for the kilo, lowercase m for the meter. A kilometer, because kilo means 1,000, is equal to 1,000 meters. So whenever you see kilo, think 1,000. In the US, we don't often use kilometers, though. What do we use instead of kilometers?
Is it miles?
It is miles. So whatever we would measure in miles, most of the rest of the world would measure in kilometers. So, for example, what would we measure in miles here?
Roads.
Road length anyway. David, you had one? Sure. So let's say driving distances. That'd be good. So that would be your house to the school, or my house to the school, or sit between cities. Anybody have another one? Yeah.
Don't they sometimes measure the depth of the ocean?
Sure. You bet. At least in the deepest parts, it would definitely be in miles. Good. Let's look at the next one then. Let's go, we're not gonna, nobody measures anything in megameters. It's just not something that's used. If we were going to measure lots and lots of kilometers, say from the Earth to another planet or even the moon, we would probably use kilometers, but then we'd use the scientific notation that you had mentioned. We're not going to practice that really too much in this class, so we're not going to worry about it today. But it'd be related back to kilometers or perhaps meters, but it'd be in some sort of scientific notation. We will get smaller though. So centi we abbreviate with C, and it means small. So think of money when we see this. It takes 100 centimeters to equal 1 meter. Just like it takes 100 $100 to equal a dollar. And a century is 100 years. That's a little backwards, the way of counting, but it means the same thing, 100. And this the prefix goes back to Latin. A commander of 100 men in their army. It was called a centurion. Same reason. What would we, so centimeter is about that far, around the width of your pointer finger, if you have average sized pointer fingers. Which most people in here will, or maybe go that way. If you got real big fingers, maybe it's your pinky, but it's around the width of a finger. What would we use in English or in imperial measurements instead of centimeters? Yes,
Inches.
inches. Yeah, you bet. We would use inches in the US. So a centimeter takes the place of inches. So some examples. What would we measure in inches normally? David? Sure. Computer screen, TV screen, stuff like that.
Wood, like for woodworking.
You bet. Woodworking. Yeah. Anytime you're building relatively smallish stuff. We know inches. We'll just put a couple of examples. And then, no, we'll do both. This won't be quite our last. Let's talk about millimeters. So milli gets the abbreviation of lowercase m, and meter gets an abbreviation of lowercase m. So we have little mm, and milli means 1/1000. So very, very small. So it takes 1,000 of those millimeters to make 1 meter. And again, milli meaning 1/1000th. If you take 1,000 of them, then you have whatever is next. And that is a small measurement right there. We don't really have anything in the US that, any named measurement that takes the place of this really. What's that? We'd use fractions of inches, exactly. So instead of doing fractions like 1/2, 1/4, 1/16, 1/32, if you're woodworking, you might get that fine or some other things. We would use millimeters in the rest of the world. So I'm going to say it'll take place of fractional inches. So we might use them as part of a measurement, say if we're trying to do fine work for woodworking or something like that. But what would we measure on its own in units that are, 1 to maybe 10 of units that are this big? What's that small around us?
Thickness of pencil lead.
Yeah, pencil lead. If you've got a mechanical pencil and you look on it, the ones I prefer say 0.7. That means the thickness of the graphite in here is 0.7 millimeters. They come in 1.0, which is 1 millimeter in diameter, and they come in 0.5, which is half. So, and if you've got a wooden pencil, it's probably a bit over, maybe even a couple millimeters. What else would we measure in units that are that tiny? That might be 1 or 7 or somewhere around there. Not air. Bugs, insects would definitely. So ants, mosquitoes, that sort of thing. Most small insects anyway. Not like giant cockroaches. Tiny, tiny things. Thickness of a coin would be a good one. Now, if we looked at the diameter of a coin, like a quarter, That probably wouldn't be millimeters, what would that be? Probably centimeters. But the thickness is quite small, so we definitely use that. So good examples. We're going to do one more for length, which is micrometers. And that one, the micro gets the little kitten sound, mu. We would just say it micrometers. But this micro means 1/1,000,000th. So it takes 1,000,000 of these. Equal 1 meter. And again, we don't really have an American or English equivalent. We would use thousandths of an inch or even smaller, millionths of an inch to do that. And that's a pretty uncommon measurement for most of us. We do still see stuff that we would measure in micrometers, which is sort of, it's getting to the limit of what we can see with the unaided eye.
Maybe like cells.
Cells would be, I think. Let's double check how big a cell is. But I think cells would probably be on the order of correct. So let's, and different cells obviously would be different. Let's check that. So this is, so most are actually even a fair bit smaller than this. So viruses are, these are nanometers, so this would be 1/1,000,000,000th. So if you took one of these micrometers and cut it up into 1,000, then you'd have nanometers, and that would be there. But those cell types, so we're going to see a couple different cell types. So viruses are tend to be very, very small. Neurons, which are what? Electrical, but what do we call them? Not a nucleus. What's a more common term for a neuron? They deal with electrical signals through our body. Nerve. They're nerves. They can have lengths of a meter, it says, because one neuron might stretch up down our length, but a width of only 10 microns. So that'd be pretty close. Yeah. Mature female egg cells, around 120 microns. So quite a few different cells. Bone marrow cells responsible for production of blood platelets, and I don't know, muscle fiber cells are maybe 100 microns in diameter. So a micron is a good measurement for quite a few different types of cells in biology. A bit bigger, but still measured in microns. Hair. I wasn't just doing this because I'm itchy, but it does feel nice, so I'm going to keep doing it. Hair diameter, for sure. And that would be a lot of, now we're getting to the range of hundreds of microns for hair diameter. So, and it's still pretty thin. Spider, probably spider silk, you bet. Because that is finer than hair for sure, but not as small as cells typically. So, good examples there. Any questions on any of the length measurements or distance measurements? We got time, plenty of time to do at least one more. Now, and I'll say too, that although this wasn't on our original plan for today, it's not all bad that we're doing it now. Let's talk next about mass measurement. Does anyone know what mass means? Yeah, please.
Isn't the outside of
No, it's not. It's not the outside of the object. We know what it means to be massive, right? What does it mean to be massive? Usually big, but definitely what else? It's not the space, and that's what I mean. It's things that are massive are often big, and that means space. But what else does it always mean? Heavy. It's related to weight, but it is not weight. Mass describes basically how many atoms or how much matter there is in something. So I'll say how much matter something contains. It is different than weight because weight is really the force of gravity acting on us, and weight depends on mass, but it also depends where you are. The moon, your weight would be very, very different than it is here, but your mass would be the same because you would be made up of the same amount of matter whether you're here or on the moon. That said, most of the world uses mass measurements instead of weight measurements, which is okay because we really only make those measurements here on Earth. And so we don't get into trouble because we're not trying to share them with someone on the moon or on Mars. But just keep that in mind that it is technically something different. When we're talking about forces, we'll make an even bigger distinction than that. I have something to demonstrate this one for you. Who remembers the base unit in the metric system for mass? It's a gram. So base unit, gram. And we abbreviate that with a lowercase g. A gram is defined through the metric system using a meter. And the most common substance that everyone could relate to, water. They started with the meter and said, okay, well, let's use the meter to help us define other measurements because then we can they're all interconnected then, and we can convert. We can know, if it's this many grams, then I can figure out how big it is too. And so they said, let's take 1 cubic centimeter of water. So a cube with this big on its side, or about the width of your finger on each side. And that water we will define to have a mass of 1 gram. And that's our gram. So just like they tried to chop up the size of the earth and make that a meter, they said, well, if we chop up a meter, we can make that into a gram. This little thing is a gram. It's a thin piece of aluminum. I'll pass it around so that you can feel it. So if you had a 1 centimeter cube of water, which is also the same as 1 milliliter, which we'll talk about next, it would have the same mass as that. Change my color scheme here. What would we use in the US to measure essentially weights, but masses, instead of a gram? So anything we would measure with ounces, the rest of the world basically measures in grams. What would we measure the weight of in ounces?
How much you weigh?
Probably not. So think of those little discs. What could we weigh though with, maybe even hundreds of those little discs or ounces? But not the bigger unit, not pounds. Food, probably. Yep, most foods. Or food servings anyway. A 1/4 pounder hamburger would be definitely, it's 4 ounces. That would be in grams. And people we wouldn't weigh in grams because they're too small. But what's smaller than people that we might weigh? Think of animals and things that we might weigh in grams that are a lot smaller than people. Insects, maybe. Big insects. Like tarantulas. Well, not an insect, but insects the size of tarantulas. Or spiders, because of course a tarantula is a spider. Rodents, you bet. And as you say, small rodents, so like mice and things, rats even. Some rats get really big, but not like a beaver is technically a rodent. Not a beaver, that's too big. But small rodents, mice and things. Now, that's not a very useful measurement for everyday measurements, because it'd be way too small to measure people in. We'd be hundreds of thousands potentially, or hundreds of thousands for people. So instead, we use this. This is 100 grams, a kilogram. This is a lot more useful because a kilogram works out to 2.2 pounds. So it's a bit heavier than a pound, but it's still a very useful measurement. Kilogram, kilo is K, gram is G, and kilo means 1,000. So if we have 1 kilogram, that's like say 1,000 grams. And as I already had said there, we use that instead of pounds. Now, pounds are actual weight, that's a force. Kilograms are mass, it's not a force, but for all intents and purposes, we use them interchangeably here on Earth. And for examples, now we can use Aaliyah's suggestion of humans. Even very small humans. Children, I believe they're called. Terrible things. Yep. Well, and anything like rabbit or bigger would be kilograms. So I'll say rabbit to elephant. Just not really, really small animals. Even whales. I'm gonna remove elephants. I'm gonna put whales in there. Even bigger. Everyday things. Give me a couple other everyday things that would be kilograms. Microwave oven, you bet. Microwave or even a standard convection oven. Any type of oven. So you get the idea. Books would often be kilograms. Most books. Very thin children's books. That'd be grams.
Weights like
You bet. Exercise weights, I'll call it. Okay, good. Mm-hmm. Not being, yes, you certainly could. I don't know that they would measure grain in kilograms because they usually measure it in bushels, which is more of a volume, I think. But I'm not 100% sure, not being a farmer.
So like a 50-pound bag of grain.
That would be definitely kilograms. Yeah, if it's bagged and it says 50 pounds, definitely kilograms. Yep. Yep. I was thinking like a whole elevator full. I think they would measure in bushels, which I don't know what the equivalent of a bushel is. They might even use bushels in other parts of the world. Let's get smaller. Now, nobody measures anything in centigrams, so we're not going to measure in centigrams either. We will, however, occasionally measure in the next smaller milligrams. Milli is lowercase m, grams is G. And just like before, a milligram is 1/1000th, so it takes 1,000 of them to equal 1 gram. We don't really have an equivalent. It'd be, again, now fractions of ounces. And there are a ton of things that we use it for because it is so small. That little disc I passed around, consider cutting it up 1,000 times. One of those is a milligram. So, and we're closing up on time, but let's finish this one up. We would use this for medicine doses, is a big one. So if you look at a pill, the pill itself might be 1 gram or 2. But the medicine inside it, the active ingredients, are only milligrams. If you look at, I've got sodium in here. That's in milligrams, 85 milligrams of sodium. So I'll say like sodium in soda. Only a little bit, but that's the kind of thing. So we might even do like grains of sand to give you an idea. Or I could see mosquitoes. Would be milligrams. Very, very tiny. And even a mosquito could be, I don't know, 100 milligrams, something like that. Quite a lot. We've got a little bit more to discuss. We're going to do volume and time. We'll probably start that tomorrow, but then we'll be able to finish up pretty quickly.